Hey everybody, we are live now. Uh, going to go through the harmonics lesson. Let's sign into the blended learning and I'll show you that what chapter we're in. I believe it's chapter 5 of your book. Alright, so we are in chapter 5 talking about harmonics. Uh, Harmonics are uh, where there's other frequencies inside the same line, and it causes all sorts of issues. Um, like you can see in this little introduction, it's been increasing it more and more uh, as we get more computers, and these little charging blocks have cause harmonics. LED fixtures, fluorescent fixtures cause way more, so it's actually getting better. But incandescents don't cause any harmonics. They're just bad in several other ways. Uh, LEDs are really they're quite a good balance of problems to efficiency. Uh, yeah, like it says here, the ballast for fluorescent lights produce harmonics, and sharing neutrals. What harmonics do is, well, in a lighting circuit, if you're sharing a neutral, it will cause the neutral to. Let me back up. In the case where you're sharing a neutral, normally it would the amperage on the two hots would cancel out on the neutral, and the neutral will actually be carrying just a little bit of amperage. But with harmonics, the amperages won't cancel out completely. And say you get 3/4 of the amperage from one line and 3/4 of the amperage from the other line, well, now you have 150%, or 6/4 if you want to say it that way. You have 150% of the amperage that was supposed to be on the neutral on it. So now you have too much amperage on one of your lines, or on your neutral line. All right. Uh, so we're going to go through basically some vocabulary, and I'm going to try not to get too deep into all of this. Total harmonic distortion, that's the word for how much harmonics distortion there is. I mean, that's pretty straightforward. Negative sequence harmonics have the fundamental harmonic, or the fundamental frequency, is the normal current. That's what you're looking for. That's what's supposed to be there. Uh, Negative sequence harmonics are 180 degrees out of phase. It's almost like it's a negative, like a photo negative. Total demand distortion is the ratio of the current harmonic to the maximum current load. Yeah, that's so that would be, you take your total harmonic distortion and find the ratio of how much harmonics, the current harmonics there are, to the actual current load. The harmonic is a voltage or current, a frequency. So let me just look up harmonics. Let me find a. Ooh, there's a good picture. Right there. Uh, Open image in new tab so I can zoom in some. There we go. I like that. Alright, so it looks like green is a normal waveform. That's what's supposed to be there, is the green line. All these others, the third and the fifth, so the third has 3 times as much frequency and the fifth has 5 times as much frequency as the normal harmonic, the normal sine wave. And whenever you combine all this together, if you looked at it with an oscilloscope, you would get the red line. Where it's trying to do its job, but it's all over the place. Alright. Only single phase loads generate tripling harmonics. Tripling harmonics are ooh, how am I blanking on that? They come from tripling harmonics are the loads that I'm talking about where they don't cancel out on the neutral. And that's the problem with them, is they don't cancel out on the neutral. If you have been following the code book, which most of y'all have not, I would assume, over the past 10 years, 15 years, more and more they're removing permission to share neutrals in different situations. There still are situations where you can share a neutral, but they are becoming less and less common. A blank power supply is a power supply for electronic devices. So this is a switched mode. This is talking about ways to counteract harmonics. And a switched mode power supply is one of the primary ways to counteract harmonics. Yeah, that's... Current crest factor is actually something we've dealt with before, but we haven't ever called it a name. It's, if you remember, whenever you have the peak and the RMS voltage, that would be that multiplier, or the thing you divide the peak by to get to the RMS. That's the current crest factor. That's what that 1.414 is. Or the multiplier of 0.707, that's the current crest factor. That's what you're dealing with that. Alright, looks like we have 5 more minutes before this quiz is supposed to come down. So I'm going to leave it up for about 5 more minutes, but I am going to get out of here. So at 4 o'clock, I will be putting up the new quiz. And at 5, I will be going live for the last time today. You guys have a good next hour.